Hey everyone, welcome back to Code in Motion. Today we're solving LeetCode problem number 19. Remove the nth node from the end of a linked list. Given the head of a linked list, remove the nth node from the end of that list and return back its head. So if we take a look at this example, 1, 2, 3, 4, 5, n is equal to, so we want to remove the second to last node, in this case 4, and the result is 1, 2, 3, 5. All right, so let's think about how we could solve this problem. This problem is tricky because we need to remove the nth node from the end of the list, right? If we could have removed the nth node from the beginning of the list, this would have been an easier problem. We could have just traveled n in the beginning, and then we know that we delete the nth node. But what makes this tricky is we need to delete the nth node from the end. And one approach is to basically traverse through the linked list, get the size, and then retraverse through the linked list. But I want to see if we could do this in one iteration, right? And so let's use this concept of traveling n from the beginning of the list. That means that the rest of the linked list is size m, right? Okay, how does that help us? Well, if we have one pointer move n, and then we start a new pointer at the beginning of the list, and have both of those travel m, that means the second pointer will end up at exactly n, right? Because if one pointer at the beginning travels a distance of m, then it ends up at exactly n, which in this case would be node 4. And that's exactly what we want, right? So we could be smart about how we traverse this linked list. And so let's actually try that. Let's initialize a pointer to the start of the head, and let's move the pointer by n steps. In this case, n is 2. Okay, so we move it once, and now let's move it again. Okay, we moved it twice. N is equal to 2, we moved it twice. Now let's initialize a new pointer at the head, and a previous pointer at null. And the previous pointer, we just need that to delete a node, which you're gonna see how we do that shortly. But right now we need access to previous and p2. Now let's move p1 till the end of the list. This is gonna be moving it m units, right? And we just saw if we move p1 and p2 m units, p2 should be equal to the node that we want to delete. And so let's move p1 again. Prev and p2 move along. Let's move p1 again. p1 is now null, so we stop the iteration. And this actually means we found the nth node from the end. We should remove node 4. And how do we remove node 4? We're going to use prev.next is equal to p2.next, right? This effectively removes the node p2. And let's do that right now. So we point 3 to 5, p2 is dropped out, and node 4 is ignored. Now the time complexity of this algorithm is O of n because we only traverse through the linked list once, and the space complexity is O of 1 because we only keep track of 3 variables. So let's code out the solution. I'm going to start by saying p1 is equal to head, and we need to move p1 n units, right? So for I in range n, just move p1. p1 is equal to p1.next. Now I'm going to initialize previous and p2, right? So previous is equal to null and p2 is equal to head. Now I'm going to say while p1, so we need to move p1 m units, right? We're moving it to null, essentially. We're going to move p1, so p1 is equal to p1.next. Previous is equal to p2, and then p2 is equal to p2.next. Now we basically need to delete the node at p2. By saying previous.next is equal to p2.next. However, we need to be very careful here. There is an edge case, the edge case where we need to delete the head. If we need to delete the head, that means previous is null, right? So I'm going to say over here, if not previous, that means previous is null, return head.next. That means we just need to delete the head. Else, we're going to use previous.next is equal to p2.next, and we're going to return back the head. Let's run this and make sure that it succeeds. And there we have it. Thank you so much for watching. If you're interested in the Blind 75, be sure to subscribe and like the video down below. I'll see you in the next one.